What if I told you that right now, somewhere in the universe, a star is exploding with enough force to outshine an entire galaxy of 200 billion suns combined? And here's the disturbing part. When one of these cosmic monsters detonates, it releases more energy in 10 seconds than our sun will produce in its entire 10 billion year lifetime. These aren't your average supernovae. These are hypernovae, and they're the most violent explosions in the universe since the Big Bang itself. In April 1998, astronomers detected something that shouldn't exist. A gamma-ray burst, designated GRB 980425, released energy equivalent to 1,000 supernovae. Scientists were baffled. The standard models couldn't explain it. This wasn't just breaking the rules, it was shattering them completely. What they discovered would rewrite our understanding of stellar death and, controversially, suggest that we've been classifying cosmic explosions wrong for decades. Here's what actually happens during a hypernova, and trust me, this gets wild. When a massive star, at least 30 times the mass of our sun, exhausts its nuclear fuel, its core collapses in less than 1 second. But unlike regular supernovae, the core doesn't just collapse into a neutron star. It keeps going, compressing into a black hole while the star is still exploding. You've got a black hole forming inside an exploding star. Let that sink in. The rotating black hole then creates the most powerful magnetic fields in the universe, quadrillions of times stronger than Earth's magnetic field. These fields channel jets of matter and energy outward at 99.9% the speed of light. When these jets punch through the star's surface, they create gamma-ray bursts so powerful they can be detected from literally billions of light years away. In 2008, GRB 080916c was visible from 7.6 billion light years away, meaning the light we detected had been traveling since before Earth even existed. Now here's where it gets controversial, and scientists are still arguing about this. Some researchers claim hypernovae aren't a separate category at all, just the extreme end of regular supernovae. But the data tells a different story. In 2003, astronomers studying SN 2003DH calculated it released energy equivalent to about 50 supernovae. That's not an extreme version. That's a completely different beast. The debate continues to divide the astronomical community, with some institutions refusing to use the term hypernova altogether. But here's what really should keep you up at night. These explosions are cosmic forges that create the heaviest elements in the universe. Gold, platinum, uranium. Every atom heavier than iron in your body, and everything around you was born in these catastrophic events. That gold ring. Hypernova. The uranium powering nuclear reactors? Hypernova. We are quite literally made from the ashes of the universe's most violent deaths. And it gets more terrifying. When a hypernova occurs within 6,000 light years of Earth, and scientists calculate this happens roughly once every billion years, the gamma-ray burst could strip away our ozone layer in seconds. The radiation wouldn't just cause mass extinctions, it would sterilize half the planet facing the burst. Some researchers now believe the Ordovician extinction event, which killed 85% of marine species 440 million years ago, might have been caused by a hypernova. We found evidence of radioactive isotopes in rocks from that period that don't match any Earth-based source. In 2022, astronomers detected the brightest gamma-ray burst ever recorded, designated GRB 221009A, nicknamed the boat, brightest of all time. It was so powerful it disrupted Earth's ionosphere from 2 billion light-years away. Instruments designed to measure these events were literally blinded. If that hypernova had occurred in our galaxy at the wrong distance, you wouldn't be watching this right now. None of us would be here. The closest potential hypernova candidate we currently know about is Eta Carinae, 7,500 light-years away. This monster star is 100 times the mass of our sun and could explode any moment in cosmic terms, meaning tomorrow or 100,000 years from now. When it does, it'll be visible during daytime and bright enough to read by at night. But here's the catch. It's pointing the wrong way. Those deadly gamma-ray jets? They're aimed away from us. Pure cosmic luck. Recent studies using data from the James Webb Space Telescope have identified over 40 hypernova candidates in distant galaxies, and the frequency is higher than predicted. A 2023 paper published in the Astrophysical Journal suggests these events might be 10 times more common than we thought, especially in the early universe when massive stars were more abundant. This means hypernovae played a bigger role in shaping the cosmos and seeding it with heavy elements than any previous model predicted. What makes this even more mind-bending is that we're watching ancient history. Every hypernova we detect happened millions or billions of years ago. We're seeing the death screams of stars that exploded before humans existed, before dinosaurs walked Earth, before Earth itself formed. We're witnessing the past, and those same explosions are still happening out there right now. We just won't see them for millions of years. So if you want to stay updated on the universe's most extreme phenomena and discoveries that challenge everything we think we know about cosmic events, follow this page for more content that'll blow your mind harder than a hypernova. Now here's my question for you. If scientists detected a hypernova forming in our galaxy today and calculated it would explode within our lifetime, would you want to know, even if there was nothing we could do about it?